Welcome back, children. We can do problems. The first question. Let R be a relation from n to n. N means set of natural numbers defined by R is equal to set of ordered pair AB such that AB belongs to n and A is equal to B square. Are the following true? First one, ordered pair AA belongs to R for every A belongs to n. Second one, ordered pair AB belongs to R implies ordered pair BA belongs to R. Third one, ordered pair AB and ordered pair BC belongs to R implies ordered pair AC belongs to R. Justify your answer in each case. So, one relation is given. R is a relation. R is a relation from n to n. R is a relation from n to n. It is defined. How R is defined? R is equal to ordered pair AB such that A is equal to B square. This A and B are natural numbers. Okay. So, we can say that is 1 is in R. 1 belongs to R since A means 1. 1 is equal to B square. 1 square is equal to 1 itself. So, I can say this 1 is an element of R. The same way 4 2 is an element of R since A means 4. 4 is equal to 2 square. So, which all pairs in this R? I can write 1 is an element of R, then 4 2 is an element of R, then 9 3, 16 4. The first element is the square of the second one. Okay. In that way we can write 25 5. So, these are elements of R. The question is this one AA? AA belongs to R for every A belongs to n. This 1 is an element of R. It's correct. Then what about 2 2? Is 2 2 belongs to R? No. This 2 2 not belongs to R since 2 is not equal to 2 square. The first 2 is not equal to second 2 square. 2 square is 4. So, only the 4 2 is an element of R, but 2 2 is not an element of R. 3 3 is not an element of R. 4 4 is not an element of R. Only 1 is an element of R. The statement is AA belongs to R for every A belongs to n. Natural numbers, there are infinitely many natural numbers. This relation is true only for one pair. So, we can say that this AA is not belongs to R for every A belongs to n. Only for one natural number 1 that belongs to R, but for not any other natural number it is not true. Now, the second case, AB belongs to R implies BA belongs to R. So, look here, 4 2 is an element of R since 4 is equal to 2 square. Is 2 4 belongs to R? 2 4 belongs to R means the first element is equal to second element square. Is it true? No. So, 4 2 belongs to R does not imply 2 4 belongs to R. So, we can write AB belongs to R does not imply BA belongs to R. Okay. You have to write the reason. What is the reason? You can give one example. Since this element 4 2 is an element of R, but 2 4 not an element of R. Okay. Now, the third one is AB and BC. AB, the second element is B, here the first element is B. AB, BC element of R, then AC is an element of R. So, you have to take such pair AB and BC. So look, 81 and 9 is an element of R, since 81 is equal to 9 square. Okay, so 81 9 is an element of R. Then here 9 3 is an element of R, since 9 is equal to 3 square. So we have the pair AB and BC. These two are in R. Then what about AC? What is A here? 81, C is 3. Is 81 is equal to 3 square? No. So this statement is wrong. AB and BC belongs to R does not imply AC belongs to R, because of this reason. So 81 9 is an element of R, 9 3 is an element of R, but 81 3 does not belongs to R. Therefore, AB, BC belongs to R does not imply AC belongs to R. Understood all of you? So the first one is AA not belongs to R, since 2 2 3 3 4 4 these are not in R, only 1 is an element of R. Then the second one is, if AB is an element of R, then what about BA? So we took one example, 4 2 is an element of R, but 2 4 is not an element of R. Then the third one is AB and BC element of R. What about AC? So we took one example, 81 9 and 9 3. These are in element of R, since they satisfy the condition A is equal to B square. But when we take A and C, 81 and 3, 81 is not equal to 3 square. So AB and BC belongs to R does not imply AC belongs to R. Now the second question. F be a subset of Z cross Z, defined by F is equal to set of ordered pairs AB, A plus B. A and B are integers. Is F is a function from Z to Z? Justify your answer. So F is a subset of Z cross Z. So F is like ordered pairs. The first element and second elements are integers. Okay. Then we have to check whether this F is a function or not. Function means every element has one and only one image. So here I am taking example. We can't check. Integers means there are infinitely many numbers. So it is very difficult to take all the numbers. So if A is equal to 1 and B is equal to 2. Okay. Then what is A into B? 1 into 2 is 2. And A plus B. From here, AB and A plus B. A plus B is 1 plus 2 is equal to 3. So, this, what is the first element? 2. 2, 3 is an element of F. Okay. F means set of ordered pairs. Ordered pairs are AB and A plus B. If we take any two element, if you take 3 and 5, 3 into 5, that is 15 is the first one, then 3 plus 5 is the second element, like that. So many pairs are in F. We have to check whether F is a function or not. So this 2, 3 is an element of F. Then I can give negatives also, since the set is integers. A is equal to -1 and B equal to -2. What is AB? -1 into -2, negative into negative, positive. And A plus B is -1 plus -2. Okay. So I can write 2 minus 3 is an element of F. Okay. Now what is the image of 2? 3. What is the image of 2? -3. So how many images for 2? There are 2 images. So you can take like this so many examples. This one example only. So from this we can say that this F is not a function. Since 2 has two different images, not a unique image, two different images. F is not a function. F is not a function. Okay. Now the next one, find the range of the following functions. Range means set of y values, set of second values, or set of this f of x values. F of x is denoted as y. Okay. So that is known as range. So we have to find the range of the function. Here the function is defined as 2 minus 3x, where x is a real number and at the same time x is greater than 0. So for finding the range, you can give f of x as y. Set of y values, that is known as range. So y is equal to 2 minus 3x. Okay. Then after this step, write what is x. Always this is the step for finding the range. Put f of x as y, then after that write x is equal to. So I take this 3x to this side, 3x is equal to 2 minus y. Okay. And x value is given as greater than 0. X is a positive number. Since x is greater than 0, it is given in the question. 3x is greater than 0. X positive means 3 into positive number is greater than 0. Therefore, so this left hand side is positive, means left and right equal, means this is positive, means this total value also positive. Therefore, 2 minus y is also greater than 0. Or we can say 2 is greater than, take y to the other side. Or we can write 2 is greater than y means y is less than 2. Y value is known as range. So y values are less than 2. Less than 2 means minus, when we write as interval. These are real functions. Domain and range, set of real numbers or subset of that. So here y value less than 2, that is range is equal to, from where to where, minus infinity to 2. Then less than only, so not closed one, it is open. Infinity side is always open. So range of this function is minus infinity to 2. Once again, for finding the range, you have to write f of x as y, and in the next step write x. So 3x is equal to 2 minus y. Since x is greater than 0, 3x is also greater than 0. So the right hand side must be greater than 0. So 2 is equal to greater than y, or y is less than 2. So y value means set of real numbers less than 2. That is minus infinity to 2. Next one, f of x is x square plus 2. X is real number, it is given. So domain means set of real numbers. What is the range? So y is equal to x square plus 2. Okay, x square means x square is a positive number, always 0 or more than that. So x square I can write as x square is equal to y minus 2, isn't it? And x square is always greater than or equal to 0, isn't it? So this part is greater than or equal to 0 means y minus 2 also like that. So y is greater than or equal to 2. Okay. Y is greater than or equal to 2 means what is the range? Range means y values 2 and more than 2. So I can write 2 to infinity. Infinity open. 2 here equal sign, so it is closed. Okay. Look once again, f of x as y, y equal to x square plus 2. After that write x square. X square is equal to y minus 2. X square means square of a number. Square of a number is 0 or more than that. It cannot be negative. So we can write x square is greater than or equal to 0. So if one side is like this, the other side also greater than or equal to 0, then only the equality satisfies. So y minus 2 greater than or equal to 0, or y is greater than or equal to 2. So y value range is equal to 2 to infinity. Now the next one, f of x is x square by 1 plus x square. This is a rational function, okay, and denominator cannot be 0. Here x is given as real numbers. Is it correct? Denominator 0 means for rational function how we find the domain? We have to put denominator equal to 0 and find the values of x that you have to delete from set of real numbers. Here when I put x square plus 1 is equal to 0, x square is minus 1. So x is equal to plus or minus root of minus 1. That is an imaginary number, no real number satisfy this condition. Okay. So imaginary number, that is complex number. So for real number you can give any real number to this x. This denominator cannot be 0. That's why here it is given domain. X means set of, domain means set of x values. X is a real number. For all real numbers this function is defined, since denominator cannot be 0 for any real number. Clear? Now here we have to find the range. So y is equal to x square by 1 plus x square. Either you can divide, since the degree of the numerator and degree of the denominator same, you can divide. Another method is denominator 1 plus x square. You can add 1 and subtract 1. Okay. Then you have to split it. This take as one term and one another term. So that becomes 1 minus 1 by 1 plus x square. Or if it is difficult, you divide x square divided by 1 plus x square, or we have to write in standard form x square plus 1. X square by x square gives 1. 1 into x square is x square, and here nothing, plus 1. Subtract. Okay. Then how we write as mixed fraction? The quotient, remainder by divisor. So the same answer you will get. Okay. Either you follow this or this one. So y, here we write like this. Then we have to find the values of y. Here 1 minus 1 by 1 plus x square. This x square is a positive number, it cannot be negative. 1 plus x square, that should be, if x is 0, this can be 1. When x is 0, what is the y value? When x is 0, here 1. 1 by 1 is 1, so y becomes 0. Okay. Otherwise, x is always greater than 0. Then 1 plus that number is more than 1. Okay. More than 1. 1 by more than 1 is, when we divide, it is smaller value, that is less than 1. So 1 minus that is less than 1. Okay. So maximum you get y as 0. All other values are less than 1. Is it correct? Once again, y means 1 minus 1 by x square. This x square means it is 0 or more than 0. When x square is 0, you will get answer as, that is y as 0. When x is 0, you will get y as 0. Then other possible cases are x positive numbers. If x is positive number, 1 plus that number is more than 1. 1 by that is less than 1. So 1 minus small value means it is less than 1. It cannot be equal to 1. Equal to 1 means this part, this complete part becomes 0. That is not at all possible. So you will get y as, y belongs to which interval? 0 you will get, and maximum 1 you won't get. 1 is open, 0 is closed. So this is the range of the function. Okay. So first I simplify this. Otherwise, usually what we do is f of x y, then after that you have to find x. But here x square, 2x squares are there, so it will be little difficult. That's why I write like this. This is the simplest form. When I divide or like this, add 1 and subtract 1, you will get y as like this, 1 minus 1 by 1 plus x square. Then you have to think, when x square is always a positive number, 0 or more than 0. When x square is 0, you will get y as 0. Then all values are more than x values, x square values are more than 0. 1 plus 0.1 or 0.5. So if you add it, it will be more than 1. 1 by that number is less than 1. 1 minus that is less than. So you won't get 1 answer as 1 or y as 1, you will get less than 1. So range is equal to 0 to 1. 0 is closed. When x is 0, you will get y as 0. But you won't get any value when you put x as any number. If x as 100, its square is more than that 10,000, you will get plus 1 is 10,001. 1 by that is very small value. 1 minus that is less than 1. So like that. So the range is 0 to 1. 0 is closed, 1 is open. Now the next one is find the domain and range of the function. It's a modulus function. Modulus function, domain is set of real numbers and range is 0 to infinity. 0 is closed, infinity is open. Here we have negative sign. Domain anyway, domain means set of x values, which all values you can give to this x. You can give any real number, no restriction for that. But what is range? Usually modulus function range is 0 to infinity. Okay, that is for the on the number line, this is 0. This side is the range of modulus function. But here we have negative of this. That means you will get all answers are negative. That is negative sign. So what you have to write? Negative infinity to 0. Just opposite of modulus function. Here it is negative mod x. That's right. Then here it's also modulus function. You can give any real number to this x. So domain equal to R. Domain is R. What is the range? Modulus function range is, modulus means whatever number you have given, the answer is a positive number. 0 you will get or more than 0. You won't get any negative number. So I can write when x, I can give x as 1. When x is 1, you will get 0. Then if you give any negative or positive number, then you have to do the operation and write answer as without sign. That is, it cannot be negative. So I can write the range as 0 to infinity. That is the range of that. Now the next one, f of x is root of x minus 1. We have to find the domain and range. For domain, children, you have to consider only this part. So I am taking that x minus 1. Then we have studied this root of a number is always greater than or equal to 0. Okay, that is root of whatever inside here, it is 16, 25, 28, whatever, it should be greater than or equal to 0. You have studied in the last year, if it is root minus 14, that is an imaginary number. Okay, that is not a real number. So here we are considering only real functions. So this root should be, wherever you see this root sign, you have to write it should be greater than or equal to 0. Okay. Now you have to square it. Then only we get the value of x. When we square, it is x minus 1. So x is greater than or equal to 1. That means what? X value is more than 1. 1 or more than that. So I can write domain is equal to 1 to infinity. That is the domain. Now we have to find range. For finding the range, put y equal to. Let y is equal to root x minus 1. Okay. Now y square, you can square it, x minus 1. X value or x is equal to y square plus 1, isn't it? X values, look the x values, starting value is 1 to infinity. When I give x 1, this 1 and 1 cancel, so we get y square equal to 0. Y square 0 means y is also 0. Then 1 to infinity means 2, 3 or 1.5, 3.5, whatever value be there, then that minus this. So it cannot be negative. Okay. This y cannot be negative. The minimum value of x is 1. When we give x as 1, you will get 0. Then more than that, 2, 3, 4, 5, 100,000 like that, you will get a positive number. So I can write range as 0 to infinity. This root of x minus 1, x values are 1 to infinity. So when we substitute 1 to infinity, this part cannot be 0. The smallest value you will get as 0. Then more than that. So range is equal to 0 to 1. Okay. 0 to infinity. Now the next one, f of x is root of 9 minus x square. Here also, for finding the domain, write 9 minus x square greater than or equal to 0. Or 9 minus x squaring greater than or equal to 0. 9 is greater than or equal to x square. Or I can write x square less than or equal to 9. One method is, look, I take 9 to left side. Okay. After that factorize. A square minus b square form. So a minus b into a plus b. That is product of two numbers less than or equal to 0. Product negative means one is positive, one is negative. So there are two cases, either x minus 3 positive, here less than or equal, that's why I am giving equal symbol also. One is positive, the other one is negative. Or x minus 3 is negative and x plus 3 is positive. Two different cases. From this I can write x is greater than or equal to 3. And here x is less than or equal to minus 3. Now x greater than or equal to 3. Substitute here. When x is greater than or equal to 3, that x you can give 4, 5 like that. If x is 4, 9 minus 16. So you will get negative number. So is it possible? It is inside the root symbol. So root of negative number, that is imaginary only. So this case is not possible. This side also minus 3 less than. So I can give minus 4, minus 5 like that. If you substitute, you will get a negative number inside the root symbol. So this case, which is not possible. This case is not possible. Understood why it is not possible? Since x values are more than 3 or less than minus 3. So when we give, this x square is more than 9. So you will get a negative number, that's why. Here, or this case, x less than 3. X less than or equal to 3. So you can give 2, 1.5, 1 like that numbers. And x greater than or equal to minus 3, that is minus 2, minus 1, that portion. So this case is possible, and together we can combine these two and we can write x belongs to minus 3 to 3. Is this correct? x is less than or equal to 3 and at the same time greater than or equal to minus 3. So I can write domain is equal to minus 3 to 3. Okay. Or children, if you get like this, from this itself x square less than or equal to 9, you can write directly x belongs to minus 3, 3. Okay, from this. Those who can do, you do that way. Otherwise, you have to do these all steps. Now we have to find the range. So for finding range, put y is equal to root of 9 minus x square. Then square it. Y square equal to 9 minus x square. After that, write x square. Take x square to this side, y square to right side. 9 minus y square. X square means it is always greater than or equal to 0. So we can write 9 minus y square also greater than or equal to 0, or 9 is greater than or equal to y square, or I can write y square is less than or equal to 9. Here also, look the previous one. X square less than or equal to 9, I can write x belongs to minus 3, 3. Or another way, is minus 3 less than or equal to x less than or equal to 3. In that way you can write if it is x square less than or equal to 9. The same way here y square less than or equal to 9. So I can write minus 3 less than or equal to y less than or equal to 3. But what is y? Y is the root. Root cannot be negative. Since y is equal to root of 9 minus x square, it should be greater than or equal to 0. So here the y value minus 3 to 3. So negative part you can take since y is equal to root of 9 minus x square. So y you can take from 0 to. Therefore y belongs to 0 to 3. Okay, negative part you have to neglect. Or range is equal to closed interval 0 to 3. Here directly I wrote, okay, this step. Or if you want to factorize, children, you can factorize from here. Okay, y square less than or equal to 9, or y square minus 9 less than or equal to 0, y minus 3 into y plus 3 less than or equal to 0. That means one number positive, one number negative, or second case y minus 3 negative, y plus 3 positive. From this y is greater than or equal to 3 and y is less than or equal to minus 3. Okay. So y is greater than or equal to 3. When y values are more than 3, it cannot be less than or equal to 0. Or y less than or equal to minus 3. You can give y as negative 4, negative 5. Then also it is not less than or equal to 0. So this case you can't take. And from here y is less than or equal to 3 and y is greater than or equal to minus 3. Y is less than or equal to 3. That is, when you take y equal to 3, you will get 0 value. When y square, that is when you take 2 or 1, it is less than or equal to 9. That is correct. Y greater than or equal to minus 3. That is also possible, but y value means root of this. It cannot be negative. That's why we take from 0 to 3. Negative value you have to neglect. Okay. Those who can write directly y square, if it is less than or equal to, then only you can write like this. Okay. So better you learn this. If x square less than or equal to 9 or y square less than or equal to 9, that is in between minus 3 to 3. Okay, otherwise you have to do these all steps. It will take time. So I hope this one is clear. Root of 9 minus x square, for finding domain you have to put it is greater than or equal to 0. So after these two steps you will get x square less than or equal to 9. So you can write x is in the range minus 3 to 3. Okay, so domain is, where is domain? Minus 3 to 3, closed interval. Then for finding range, put y is equal to root of 9 minus x square, square it, find x square is always greater than or equal to 0. So y square is 9 minus y square greater than or equal to 0, or y square less than or equal to 9. From that you can write minus 3 less than or equal to y less than or equal to 3. So y is in the range minus 3 to 3, but negative part you can take since y is the square root. So you can take y as 0 to 3 or range as 0 to 3, closed interval. Now the fifth one, root of x square minus 4. We have to find domain and range. So domain, for finding domain, take the right side. Root is always greater than or equal to 0. So x square is greater than or equal to 0. So what is the value of x? Or you can factorize x square minus 4 is greater than or equal to 0. Here squaring now. Factorize x minus 2 into x plus 2. Product is positive means either both are positive or both are negative, or x minus 2 negative, x plus 2 negative. So x is greater than or equal to 2, x is greater than or equal to minus 2. Then here x is less than or equal to 2, comma, x is less than or equal to minus 2. So x square greater than or equal to 4. Here x is on the number line, here minus 2, here 2. X is greater than or equal to 2 means from here. X is greater than or equal to minus 2 means from here to infinity. And here 2 minus 2. X is less than or equal to 2. 2 to minus infinity, minus 2 to minus infinity. So which is common? Common portion here 2 to infinity. 2 to infinity and minus 2 to infinity. The common portion is 2 to infinity. Is this case possible, children? Look here, x square greater than or equal to 4. Can I give x as 1? Is 1 square greater than or equal to 4? That is not possible. More than 2 is possible. When x is 2, you will get 4. When x is 3, it is greater than. So you can take only this portion, 2 to infinity. Then only this case, this condition satisfy. Like that here, this portion you can't take, since in this range the numbers minus 1, 0, 1. When we give x as these values, it is not greater than or equal to 4. So the condition is only this portion, that is minus infinity to minus 2. So here look the symbol, in the previous question it is less than. Do you remember? If it is x square is less than or equal to 4, you can write minus 2 to 2. This way you can write if it is less than or equal. Here it is x square greater than or equal. So you have to write x as the square root of 4 is 2. 2 to infinity and minus infinity to 2. Both this interval satisfy. So you have to write as union. Okay. So here I am writing, rubbing this. So from this I can write the domain is equal to 2 to infinity and minus infinity to 2. This is the domain. When x value is 2 or more than that, this condition satisfies. When x value is 2 or less than that, this condition satisfies. So you can write domain as 2 to minus infinity to 2 union 2 to infinity. Okay. Now, what about the range? So those who can directly write this, after this step you can directly write this. No need of these all steps. Okay. Now we have to find the range. For finding range, put y is equal to root of x square minus 4. Then square it. Y square equal to x square minus 4, or x square is equal to y square plus 4. May I write? Or what about this x square? It is always greater than or equal to 0. So y square plus 4 is always greater than or equal to 0, or y square is greater than or equal to minus 4. But y square means it's a positive number. It cannot. So here this value means y is y belongs to the square root of 4, that negative side to infinity. That is the meaning. But y is the root. So we can't take that negative side. You can take more than that. So I can write y belongs to 0 to infinity. Okay. So here look x values. The minimum value is here 2 to infinity. Here all negative. If you give negative value, you will get great big values. Okay, higher values. Higher value minus 4 is the positive number, definitely you will get. Then when you give x as 2, you will get 0. 2 square minus 4 is 4 minus 4, that's equal to 0. So you will get 0 and positive part. You won't get any negative number. So y is equal to, y belongs to 0 to infinity, or I can write range 0 to infinity. It cannot be negative. Okay. Now the other question, f of x is equal to 1 by root of 9 minus x square, and here the root is in the denominator. So for finding domain, we have to take the right hand side, that is 1 by root of 9 minus x square, and it is like rational function. So denominator cannot be 0. So we can write this 9 minus x square. Usually the root we can write this is greater than or equal to 0. But here, since it is in the denominator, it cannot be 0. So I have to give greater than 0. Now square it. 9 minus x square is greater than 0, or 9 is greater than x square, or x square is less than 9. So when x square less than 9, how can we write? Minus 3 less than, if equal is there, put equal symbol, otherwise like this. Okay. So we can write domain as open interval minus 3 to 3, not closed interval, open interval. If you put closed interval, this x you can give 3 and minus 3. So this denominator becomes 0. That's not possible. So you can give in between that values only you can give. Now for finding range, put y is equal to 1 by root of 9 minus x square. Square it. Y square equal to 1 by x square. Take x square to the left hand side. Or 9 minus 1 by y square is equal to x square. Okay. For finding range, always you have to write what is x. X or x square. Then since x square is 9 minus 1 by y square is greater than or equal to 0, or 9 is greater than or equal to 1 by y square, or 1 by y square is less than or equal to 9. Oh, one more thing, y square I can take here. Okay, y square is greater than or equal to 1 by 9. So when you take the root 1 by 3, you will get 1 by 3, and y square greater than or equal to 1 by 9 means, children, do you remember here what did we write here? Look, x square greater than or equal to 4. We write like this. The same condition for the y square greater than or equal to 1 by 9 means minus infinity to minus 1 by 3. Closed union 1 by 3 to infinity. That is the case. But here, since it is y is greater than, y means 1 by root. This root part is always positive. We won't get any negative answer. Okay, we won't get any negative answer since denominator is root. Root is always a positive number. 1 by of that is always positive. It cannot be negative. So this part you can neglect. So y is equal to 1 by 3 to infinity. That is range. Okay, once again. The first is for finding domain. Take the root. It is greater than 0. It is not greater than or equal, since it is in the denominator. It cannot be equal to 0. So greater than 0. Then square it. So x square less than 9. When x square less than 9 or less than or equal to 9, you have to write like this. Minus 3 less than x less than 3. If it is equal, put equal symbol. So domain is equal to minus 3 to 3, open interval. Then for finding range, put y equal to f of x. Then squaring. Take x square to the left hand side. Okay. You have to express what is x square. X square is always greater than or equal to 0. 9 minus 1 by y square greater than or equal to 0, or 9 is greater than or equal to 1 by y square, or cross y square here, 9 here. Okay. So y square greater than or equal to 9 means either the case is 1 by 3 to infinity and minus infinity to minus 1 by 3. That are the two cases. But since y is equal to this root, it cannot be negative. So negative side you have to neglect, and 1 by 3 to infinity.